Okay, today we're going to be going over similarity of triangles and angle-angle similarity. It says two polygons are said to be similar to each other if all the angles are congruent and all the sides are congruent. So today we're going to be focused more on not congruency, where everything is exactly the same, but rather similarity. Okay, so we're going to say that it's similar if all the angles are congruent and all the sides of the are proportional. That's not the same thing as congruent, okay? And you'll see what I mean by proportional in a little bit. So let's take a look at these two shapes. The first thing I would say, if you looked at those two shapes and you were to ask, someone who's 7 years old, like, hey, are those two shapes the same? I think they would probably say no. One's a rectangle, one's a square. So already we can kind of verify just by that piece of information that these are not going to be similar. But let's go ahead and go through the actual definition. First, I'm going to check if the angles are congruent. Then I'm going to check if the sides are proportional. So I'm going to go ahead and focus in on the angles first. I'm going to see are the angles are congruent. Well, this 90 and this 90 are the same, so they are congruent. This 90 and this 90 are the same, so they're congruent. Same thing with these two 90s and with these two 90s. So as far as the angles being congruent, like that's going to be good. So far, we're okay in the definition of similarity. The next thing I'm going to check is if the sides are proportional. Okay, so I'm going to go ahead and check sides, matching sides that is, and see if those are proportional. Proportion means a fraction. Now you have options. You can either make this fraction 4 over 2 or you can make it 2 over 4. It doesn't matter, but once you pick one, we're going to go ahead and stay consistent with it. Okay, I'm going to go the big number divided by the small number. So it's going to be big over small, which means I'm going to write 4 over 2. And when I divide 4 divided by 2, I get 2. Now that I decided to go big to small, you need to stay consistent the rest of the way. So the next time I start checking my other sides and see if they have the same proportion, I need to do it in the exact same order. So I'm going to take the 12 and the 2. Again, I decided big to small. Now I have to put the big one on top, which is the 12, and then the small one on the bottom. 12 divided by 2, that's going to be 6. And I noticed that these proportions are not the same. The first proportion gave me a 2. The second proportion gave me a 6. So I'm going to say these are not proportional. So let's see, what am I going to jot down? I'm going to jot down that the angles are congruent, but sides not proportional. And since the sides are not proportional, then I'm going to say that the shapes are not similar. Similar is going to be denoted with that squiggly line that I just drew right there. So I proved that these are not similar because the proportions were not matching up. Let's take a look at the next one. I can do the proportions, but first you should focus on the angles and see if the angles are congruent. Let me go ahead and do that right now. I'm going to check this 60 and see if on the other side if there's a 60 that matches up. And no, because these are all 90s, right? So already the angles are not congruent. Since the angles are not congruent, then I already know that these are not similar, okay? And again, if you were to ask like a 7-year-old kid, hey, are these shapes similar? They'd say no. One is like a diamond or a rhombus, and the other one is a square. So just kind of off of that, you would say these are not similar. But mathematically, we're going to say angles not congruent. So uh, shapes are not similar. All right, let's take a look at this one. Again, if I were to ask a 7-year-old, like, hey, do these shapes look kind of the same? I think the general answer would probably be like, yeah, they do kind of look the same. That's not enough, right? But like just kind of getting a feel for it, whether something should match up or not. Sorry about that. That is my phone. Let me go ahead and silence that for a sec. I'm going to go ahead and check, like, first, are the angles matching up? So let's see. I see that this 30 degrees matches up with this 30 degrees. That's good. I notice that this 60 degrees matches up with that 60 degrees. That's good. And I see that this 90 degrees matches up with that 90 degrees. That's good. Hey, just for a reference, so far the angles are congruent. I have just checked that an angle is the same, an angle is the same, as angle is the same. Okay, I want to kind of keep that in mind, and I'm going to reference that in a little bit. Now that the angles are congruent, I can keep going and see if I can get something else. I'm going to go ahead and match up the sides. So I'm going to see these two, the hypotenuse. So I'm going to match up the 8 and the 12. Just like last time, I get to make a decision. I can either go big to small or small to big. It doesn't matter, but once I pick something, I better stay consistent with it. So just like last time, I'm going to go big to small, which means I'm going to take that 12, put it on top, and then compare it to the 8. 12 divided by 8, that's going to give me a 1.5. That is not enough, but so far, I have a proportion of 1.5, so I've checked an S. All right, let's go ahead and check another side and see if the proportions are holding up. I'm going to check the 4 and the 6. Remember, I went big to small, so I got to stay consistent. Whatever I did the first time, I got to keep doing it. So I'm going to take that big one, which is the 6. The 6 has to go on top. 4 goes on the bottom, and oh, look at that, again, another 1.5. So far, this is looking good. I've done two sides, and they are proportional. That's not enough. I need to check all of them and see if they all work. So finally, I get to check the 4 rad 3 and the 6 rad 3. I'm going to go ahead and do the exact same thing. I'm going to divide the top, the big divided by the small. So the 6 rad 3 needs to go on the top. 4 rad 3 has to go on the bottom. I know those radicals look a little scary, but they're not. It's just they're going to cancel out. I got 6 divided by 4, which is again 1.5. And it looks like all the sides are proportional too. So I can conclude that the angles are congruent, the sides are proportional. Since both of those cases are true, then I can go ahead and say, so the triangles are similar. Okay, and that's because I got the angles to match and I got the sides to match. So basically, because of angle, 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 side, side, side. That's a ton of work, but that's okay. I mean, that's what we have so far. Okay. Again, we're going to take a look at this and we're going to see, do the triangles look like they could be kind of similar? Be like, yeah, they have the same kind of looking shape. Maybe one's a little bit zoomed in or zoomed out than the other, but they definitely look like they're matching up pretty well. As far as the angles are concerned, even though they didn't give me numbers, I know that this angle has to be the same thing as this angle because they have the same marks. I know this angle has to be the same thing as this angle because, again, they have the matching marks. And I know that this triple arc matches up with this triple arc. So even though I don't know the angle measurements, I do know that these two are, in fact, exactly the same. Okay. So as far as the angles are concerned, all the angles match up. So I can say angle, angle, angle so far. I just need to check side, side, side. So I'm going to go ahead and match up the sides. I'm going to check the sides on the right. So I'm going to match up the 30 with the 10. When I match up the 30 to 10, again, I can go big to small or small to big. And I know that since we've been doing a habit of doing big to small, we're going to go big to small. And just because of that, I'm going to go small to big. Just to switch it up a little bit, I'm going to take the small side and divide it by the big side just so you see how this would work out, okay? I would take the 10 divided by 30, and that's going to give me 0.33333 with a line on top. So far I have checked one side, but that is not enough. I need to check all three sides and make sure that they're all giving me the same proportion. So let's go ahead and check the little ones. I'm going to check the 3 and the 9. That gives me this one, and that gives me this one. So because I went small to big on the first try, I need to get consistent all the way through. So I'm going to go small to big right there. 3 over 9, that's going to give me 0.3333333 with a line on top. And then finally, that means that these two sides are proportional to each other, but that's not enough, okay? In fact, on a test, I'm going to make sure that I give you two that work and then maybe one that doesn't. And as soon as you get one that doesn't work, then automatically the sides are not proportional, okay? So last one, I'm going to check the 8 and the 24. 8 and 24, again, we're going small to big. So I'm going to take the 8, put it on top. That's going to be a 24 on the bottom. I get 0.33333 with the line on top. Angles match, sides match. I can say that these triangles are similar because of angle, 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 side, side, side. So we're going to say angles are congruent. Sides are proportional. Therefore, we do have triangles that are similar. Okay, so what do we know? What's the difference between congruence and similarity, right? The main difference between congruence and similarity is that congruence means that the angles and the size and that you have the same angles and the same size. Essentially, like if I go back to the Dorito problem, what that's telling me is that you got the exact same Dorito. So if I give one person a Dorito and the other person the Dorito, like no one should be jealous because it's the exact same Dorito. Okay. So let's see. What about for the next one? For the next one, I got similarity. Similarity means that you have the same angles, and you have proportional sizes. So that's a little bit different. That doesn't mean you have the same size. You have proportional sizes. The angles are the same, but maybe one Dorito is a little bit bigger than the other one, or maybe it's smaller. Now, I don't want to be doing angle, 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 side, 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 because that is just a ton of work. So just like last time for congruence, we had SSS, SAS, we had shortcuts. Okay. So are there shortcuts in triangles for similarity? The answer is yes. The first one we're going to be working on is angle, angle, similarity. You only need two angles. You don't even need a third one. If you can show that two angles are congruent, then we can automatically assume that the triangles are similar, which means I don't need to do all this. I can get rid of this, and just focus that's wrong. I can get rid of this, and just focus on angle, angle. Angle, angle is enough in triangles to assume that they are similar. So let's take a look at this one. We're going to do two quick examples. We're going to determine if the triangles are similar through AA similarity. All I need to show is that two angles match up. Well, the first one, I got this angle and this angle. Those match up. So I got an A. And because of the symbol, I know that this 90 degrees matches up with this 90 degrees. So I have an A. And ladies and gentlemen, instead of doing all the work that we did up here, I can already say these triangles are similar because of AA similarity. So I can say triangles similar by AA. I take a look at the next one and I go, do I have any angles? The answer is no, I don't have any angles, so I don't know if they're similar through AA. You will be able to verify later on whether they're similar, but right now we just don't have enough information. And then the last one, this is going to be the one that is going to give us a little bit of trouble. This is the one that's going to separate my A students from my B's and C's. It's questions like these. So I'm going to look for AA similarity. And the first thing I notice is, yep, I got one angle that matches. I got 40 degrees with 40 degrees. Now, the common thought would be to be like, oh, well, that's an angle, but then the other angle doesn't match. And so therefore, these are not similar. However, if you know two angles of a triangle, you should know the third. For example, so far, I know that this is 40 and 60, which means I have 100 degrees so far. If this is 100 degrees so far, then that means this last one, I can figure it out. All triangles add up to 180, so this must be 80 degrees. And since this is 80 degrees, then I do have this angle that matches up with this angle. So be very careful, okay? Especially if they give you two angles, go ahead and check that third angle and make sure that it's not like a hidden one that might pop up. So I actually do have this other angle, and since I have two angles, that's enough to say triangles are similar by AA similarity. And that's all the questions, or I'm sorry, that's all the notes we have for today. We will finish up the rest of the notes on the next page.